The book is written as the third edition. Okay, book is a third edition, but you basically can follow the second edition as well. As I stated earlier, that the benefit of using third edition is that you will easily find solution manual of all exercise questions, and then it will be good for your practice. But most of you can also use second edition as well. I have seen somewhere that the solution manual of the second edition is also available. As far as the content of this lecture is concerned, I will go through some previous material, and in the next class we will wind up with the previous material, and we will also go through the Bayes theorem. I think we have gone to we have stopped at this theorem. I think it was our last lecture when the university was open before the pandemic. So inshallah, I will go to some previous material in this lecture, and in the next lecture we will be following the Bayes theorem and some of the previous material like sampling with repetition, without repetition. These things will be covered in the next lecture. So as far as the online lecturing is concerned, I will upload. I will follow the SOP of uploading all the video lectures just before a day or two before a scheduled class, and at the timing of the class we will discuss what you have learned, and if you guys will have any question, I will answer those questions. But this is somehow a tougher course, so I will encourage you guys to practice it a lot, and I'm asking you questions if you guys have any. So let's talk. Let us talk about some of the material. Okay. Uh, okay. If you guys are getting any noise, any background noise, so I'm sorry for all that. But in online lecturing and if a guy is at home, there is a lot of stuff which is going on at the background. So you guys will have to go with it. So what is the recap? In recap, initially we have discussed what is the probability, where is it used, what are the random experiments, and what are basically the continuous and discrete probability functions. This is what we have gone through initially. Probability is basically related to a chance. What is the chance of happening some event? What is the chance of opening the university in the next week? And what is the chance of the weather tomorrow? What is the chance of a sunny day, and so on. So probability is basically the likelihood of an event to occur. It has many uses. As probability is the prediction of the future, it has nothing to do with the present, but it will take all the present and past data, and it will predict all the future outcomes. Okay? So that is the essence of probability. Where is it used? It is used in wireless networks, electrical engineering problem, computer science applications. Basically, when you will go to sixth semester and fifth semester, you will study many communication courses where probability is mostly used. Many computer networks and computer courses, probability is the basic building block of those subjects. So it is a very important course for the electrical engineers. Somehow tougher, but all the concepts are not that much difficult to cope with. So you better do some practice, and after practicing you will master the concept. Okay. The outcome of a random experiment is often assigned a random variable that is either countable or uncountable. Okay. We will discuss it. This is the topic of the third chapter, which is related to random variables, and we will discuss all of it in our in that chapter. Okay. It is also, this point is also left. So the outcome of a random experiment cannot be predicted. If as the experiment is random, we cannot predict it. Sometimes it is zero, sometimes it is one. It's like tossing a coin. If you're tossing a coin, sometimes you will get heads, sometimes you will get tails, and you cannot predict that either you will get heads or you will get tails at some time, but you will do it. You cannot predict it. This is a random experiment. Okay, the outcome is a random. But the question is, how can you find out the probability or chance of any event? So this is here. How can you find it out? You can find out the chance of the event, as I have told you that the probability of any outcome can be found out by the number of repetition of a certain event divided by the total number of repetition occurred in any sample space. What is the sample space? We have discussed it in the class. Sample space is basically the total number of outcomes which we can get in any random experiment. To find out the probability of any event, we can use the relative frequency term. You have to put the number of times an event has occurred and then divided by the total number of elements in the sample space. So, for example, if you are talking about a coin, so we have a sample space and the elements of a sample space are head. I'm sorry because I don't have marker, but I'm using touchpad. This is heads and tails, and the number of elements in the sample space are equal to 2. Let's suppose you want to find out the probability of the event that you get tails. Okay, so this is P of T. So the probability of a tail would be number of elements in the set of tails divided by the total number of elements in the sample space. So this is 1 by 2, as in n is 2, and here n of and capital N is 1. So you can see the formula here, and this is the essence of this formula. Basically, what is written here is that it is showing you what is meaning by n. What is the meaning of n? N is basically the total number of elements in a sample space. If you have gathered different events in a sample space, so every event will have certain number of elements. Just like in event number 1, you will have n1. In event number 2, you will have the element n of 2, and in event number u, you will have number of elements u, and by adding all of that, you will get n. So this is written here in this form. Okay. So n, small n is the small n is basically the maximum term which has been used here. Okay. So the probability, the most important feature of a probability function is that it cannot be greater than 1 and it will never be smaller than 0. But the value of the probability will be somehow between 0 and 1. Okay, 0 and 1 are also included. So that is that is basically the open interval, just like we said here. That is the functionality of the probability. And the second property of probability is that summation of all the probabilities will always be equal to 1. If you are doing an experiment, then the summation of all the experiments, summation of all the probabilities in that experiment will be equal to 1. And the probability of the outcome k is finding the limit out of k, and that is the limit approaches p of k. We will discuss it when we will discuss central limit theorem. Somehow uh, the concept of the next chapter. Okay. What we discussed set theory, because all the events and all the sample spaces will be described in terms of set. So in set we have a sample space, as I have told you before that what is a sample space? Sample space contains all the possible outcomes of a random experiment. Okay, as the experiment is random, you cannot say that certain event is going to occur and certain event is not going to occur. Okay, excuse me. Certain event is going to occur. Excuse me. So that's why sample space is to gather all the possible outcomes of an random experiment. So if you have a coin and you want to toss a coin 3 times sequentially, actually I have told you that there are two types of experiments. One type is a sequential experiment in which you will repeat experiments many times. But there is another type of experiment which is called a sequential experiment. What is the difference? In sequential experiment, you will suppose you have a coin and you want to perform experiment sequentially. So you will toss it 3 times. First you will toss it 1 time and you will see what is the outcome. You will toss it second time and you will see the outcome, and you will toss it the third time and you will see the outcome, and then you will say that certain event has been occurred by using the sequential experiment. Similarly, there is another type of experiment that is called a simultaneous experiment. In simultaneous experiments, you will not do it sequentially, but you will get 3 coins and toss all the 3 coins simultaneously, and then you will see what is the outcome of those experiments. And these are basically the 2 types, and we will discuss it when we will discuss binomial theorem. But here I found it feasible. I found it very important to tell you guys that what is the difference between those 2 experiments. Okay. The sample space for a sequential experiment of tossing a coin is this one. You will either get head, you will either get head, tail, and so on. And these are basically the 8 experiments. Okay. You know how they to be calculate the number of elements in a sample space. You can calculate it. I think you can calculate it. If you know, then we will see right after some slides. Okay, what is the event? Any subset of S. S is a sample space, and any subset of the sample space is called the event. Just like here, this is the event that you will get. You get 1 tail. So either you will get tail at the very first trial, either you will get a tail in the second trial, or either you will get a tail in the third trial. There are basically 3 trials, and this is the event. In words, when you will discuss, you will say that this is the event that I get only 1 tail, and you can also say that this is a subset of this sample space because this whole is this one, this whole one is this one, and this one is this one. So these three are basically these three basically composes an event which is the event that I get one tail. Okay, and this is a subset of sample set. Every element of A is also present in S. Yes, you can see that every element of every element of A is also in sample space S, and this is a simple of a sample space. Sorry, subset. That A is a subset of S. Now, A is a subset of. Let's move on. Okay, there is another operation which is that operation which is called a complement. Complement. What is the complement? Complement will tell you that if the event is A, what are the elements which are left? Okay. In uh, previous slide, you saw that HHT, HTH, HHT. These are basically the elements of A. But what will be the elements of a complement? A complement will have the element except these three elements. Okay. So if this is A, then A complement will be composed of all the five elements which were not present in A but were in sample space, and you can also see it here. Okay, so these are basically the complement, and the complement of a complement is A. Again, you can check it. Okay, the complement of a complement will be that set again. Okay, what is a union? Union and intersection, these are the important set operations. In union, we combine two or more sets in such a way that the elements of the first set and element of the second set are combined together into a third set C. Okay, this is basically the combination. As that rule is concerned, you cannot write an event or an element more than once in a set. So if an element is repeated, that will be written once in the outcomes in union, in the form of union. As far as intersection is concerned, in an intersection, the operation of intersection is to find the common element between two sets. If we have a set A and set B, so what will be the intersection? Intersection of those two sets will be the common elements of A and B. Okay, the symbol of union is this one, as written here, and symbol of intersection is this one, as written. Okay, these are basically the simple concept, and there is nothing to worry about. Let's move on. Okay, there is the concept of a null event. Null event is also a conceptual term that if nothing is happening, then that set is a null. And the basic property of null set is that it is a subset of every set. Null set is a subset of every set. So this null set is represented by phi or this empty set symbol. Null set basically it is written does not contain any sample. So if another use of null set is that if the number of common elements between two sets A and B is zero, or there is no common element between two sets, then the intersection of those two sets will be phi, as written here. A and B have nothing in common. As I have told you earlier in the classroom, that those two sets are then are mutually exclusive sets, and mutually exclusive sets are basically the most important terminologies in probability and randomization. Set equality and set differences, the two sets are uh, equal if the corresponding elements of those two sets are equal. Okay, uh, or you can say that it is written here that if A is a subset of B and B is a subset of A, so then two sets are equal. Then we can call them equal. Okay, set difference is A minus B. When you find the difference, that is X such that X belongs to A and X does not belong to B, it will cut out all the elements which are in B. If you are making A minus, if you are using A minus B, so it will cut out all the elements in the resultant set which are in B. Okay, according to this. Let's move on. Um, These are basically some properties which you guys might have seen in your matriculation, SSC, and other mathematical courses. The first property is a commutative property, and these properties are with respect to a union and intersection as well. So commutative property. This is a commutative property, and according to commutative property, A union B is equal to B union A, and similarly, A intersection B is equal to B intersection A. So these are basically these union and intersection follow the commutative property. Associative property, according to this is the associative property, and in intersection, the associative property is written like this one. Okay. Distributive property is written here, in which A union B intersection C. This is the B intersection is within the two brackets. So you will first calculate B intersection C, and then you will find the union of A with this B intersection C. It will be placed somewhere, and after it you will find out A union B and A union C, and then after finding the intersection of these two sets, you will see that the left hand side will always be equal to the right hand. Okay, this is the distributive property of union over intersection. In our left side, this is a union distributive property of union with respect to intersection, and similarly here all the operators are reversed. If it was a union there, now it is intersection here. That is therefore this property in this hand, this property is called distributive property of intersection over union. Okay, so here again you will find that left hand side is equal to the right hand side. Another very important rule that is called the De Morgan's law or De Morgan's rule. You might have uh, uh, heard about it, and I think you have also practiced it in your metric, SSC, and engineering mathematical courses. So, according to De Morgan's law, A union B whole complement is equal to A complement intersection B complement. Because here we have removed these two brackets, and after bracket is removed, this would become A complement intersection B complement. Okay, each one is complemented and the operator is reversed. Here that it is union here, but it is reversed as intersection. Similarly, if you will use intersection instead of union inside the brackets, so after opening the bracket, this intersection will be converted to union, and each set will be complemented. You can see it here. Okay, I think it's clear. But this theorem is one of the very important theorem of probability, and we will discuss it. I think you guys have also done it in TLD. Yeah, it is also a very important theorem of digital logic design, where union and intersection are basically the and or and. Union is represented as OR gate, and intersection is union. I'm sorry. Uh, and Okay, I'm again sorry for all the typos which I have been making, but as I don't have a pen, but I'm using a touchpad, so you have to make some trade-offs. I have to make some trade-offs, and you have to bear me. Okay, let's move on. This is again a De Morgan's law. Part one is a proof by Venn diagram. This is your task. And in this task, what you will have to do, you have to prove the Morgan's theorem via Venn diagram. Venn diagram is discussed in your um, Venn diagram is discussed in your classes. So please go through it, and in, in the next class you might be asked about it. Okay. Set equality, please go through it. See it that how is it calculated that A union B whole complement is a subset of um, A intersection A complement intersection B complement. A union B whole complement is a subset of that. Okay. Let's move on. Axioms of probability. What are basically what is mean by the axioms of probability? An axiom is basically a statement that is well established, taken to be true. If a postulate or a statement is given some price and it is found to be true, then it is used as the axiom of that subject. Okay, it serves as a starting point for further argument. This is the starting point, and after it you will use it. How is it found? How is it find out that this is a starting point and this is true? It is through experimentation. Certain axiom is proposed, and then experiments were performed, and after performing the experiment, if the axiom is found correctly, or I mean that the results are positive, then the axiom is approved. Otherwise, the axiom is discarded. So the first axiom of probability is that the probability of any event will always be greater than or equal to 0. It cannot be less than 0. It cannot get negative value, cannot get a value in decimals and so on. Sorry, it cannot be less than 0. It can be in decimals because decimal is 0 point something and so on, but it cannot be in negative form. Similarly, the axiom number 2 is that the probability of a sample space will always be equal to 1. As I told you earlier that the sample space is a unique set in any experiment which contains all the possible outcomes of any event. So if it contains all the events, so the probability is equal to P of x is equal to 1. And similarly, there is a third event, there is a third axiom in which which is saying by using this, if the two sets A and B, the two elements, two events, two sets A and B are mutually exclusive or disjoint, then probability of A union B will always be equal to probability of A plus probability of B. What does it mean? It has given birth to another possibility that if you don't know about whether two events are disjoint or not, then the probability of A plus probability of B plus probability of A intersection B. Okay. So probability of A union B is equal to probability of A plus probability of B plus probability of A intersection B. If you don't know about the mutual exclusiveness of two events, and if the two or more events are mutually exclusive, then the probability of the union of those elements of those events will be the sum of all the probabilities of that event. Okay. Uh, this is what we have discussed so far. I'm sharing this video with you guys, and after it, I am going to share another video in which I will be going through the other corollaries and other axioms. So thank you so much so far, and let me share it.